Hello everyone, I'm Mojtaba. Welcome back to the channel. Today we are diving into something that sounds super nerdy, but is actually fascinating. We are going to learn about obfuscation. Let's break it down together. So, what exactly is obfuscation? In simple terms, it is the art of making your code intentionally confusing and painful to read. The whole goal here is to increase analysis time and complexity, not just for humans trying to reverse engineer it, but for automated tools too. Think of it like writing a letter in a secret code, but for computers. One of the most common forms of this is packers. Now packers are basically like zip files for executables, but smarter. They compress, encrypt, or transform your executable and slap a tiny decompression stub at the front. When you run the file, that stub unpacks the original code into memory and hands over control. It's like a bouncer that lets the real code in only when it is showtime. This image here gives you a super simple visual of how packers work. But do not worry, we will also see it in action later. Next up we have MBA, which stands for Mixed Boolean Arithmetic. Sounds fancy, right? Basically, MBA obfuscation takes simple expressions and replaces them with algebraic identities that mix arithmetic and bitwise operations, like addition, subtraction, and, or, and XOR. You name it. The result is mathematically identical but an absolute mess to read. For example, check this out. Here we have y equals x times 2. Pretty simple, right? Now watch what happens when you add junk terms that equal 0, like x minus x. The code still does the exact same thing, but now it looks like a nightmare. And here's an even better example in assembly. See how ugly it gets? Alright, now let's talk about the big one, virtualization or VM-based obfuscation. This one is a bit tricky to wrap your head around because there are so many ways to implement it. So let me put it this way. Imagine you take your original assembly code and translate it into a completely custom language. Then build a virtual machine that understands that custom language. That is exactly what virtualization obfuscation does. It transforms original machine code or bytecode into a custom instruction set that only its own VM can interpret. Here is a better way to picture it. Normally, you give your CPU some code and register values. It processes them and gives you an output. Simple, right? But CPUs only understand standard assembly. So, if you throw a custom language at it, the CPU has no idea what this is. That forces anyone trying to reverse engineer it to spend a massive amount of time just figuring out how your VM works. Think of it like those crazy redstone computers people build in Minecraft. Imagine trying to reverse engineer one of those into actual code. Yeah, good luck with that. And as you can see in this diagram, this is a typical VM structure. Though honestly, everyone implements it differently. Some VMs do not even have a dispatcher. It is all about creativity. So that is a general overview of obfuscation techniques. But keep in mind, there are way more methods out there. If you guys are interested, I can totally make a part 2 and dive deeper into the other ones. Now, on the flip side, there are also tons of deobfuscation techniques to fight back against all of this. Some of the big ones include optimization-based deobfuscation, pattern recognition, emulation and tracing, and many, many more. Alright, thank you so much for watching so far. Now we're going to take things to the next level and actually look at some real-world examples. Here we have a simple program that takes a number as input, adds 1 to it, and displays the result. Now, if you're somewhat familiar with how compilers work, you know that in normal mode, my function will not be seen as a separate function in our assembly code. And as you can see here, you cannot even find it. So let us just go to the main function and see that the entire code has been optimized down to a single assembly instruction, which is inc.edx. The program is working correctly, but we want the function to not be removed. We want more assembly code to exist inside our function. So we can simply turn off the optimization settings in our compiler. This actually helps with obfuscation a little bit automatically. Now, Let's go and see what changes have happened to our executable file after building the project. As you can see, now we can find my function. Even more, there is extra and redundant code allocated to it. Alright, now let's go and obfuscate our program using different methods. First up is the packer. But first, let's take a look at the sections of our executable. These are the sections of a normal program. For example, the .text section contains the program code. Now we can simply use UPX, which is an open source tool, to pack our program. As you can see, the size of our executable has decreased. Now, if we go and check the sections, you will see that they have changed. So let's take a look at what has changed in the executable. You can see that my function no longer exists. But if we run the program and go to its relative virtual address, you will see that the code is actually there. Now, we just need to run the program from the beginning to see that this address is initially empty, and later the program data is written into memory. You can even figure out which part is responsible for writing into memory. So it is probably very clear to you now how packers work. And as you can see, the program performance has not changed at all. Alright, now let us move on to MBA, which is one of my personal favorite methods. For MBA, I am using Alcatraz, which is an open source tool. We can ask it to only obfuscate our specific function. Now, let's go and see what has changed in the executable. As you can see, the code has changed a lot. Let's just give an input to the function and see how these codes are doing exactly the same job as the original function. Yes, you can see it has added 1 to the input and the output is 8. Alright, finally, let's move on to VM-based obfuscation. For this, I am using VM Protect, which is one of the best tools in this field. In this tool as well, we can ask it to only protect our specific function so that performance is less affected. Of course, this tool has a lot of settings which are out of the scope of this tutorial. We just need to wait a bit. As you can see, the program functionality has not changed at all. But look at how much the file size has increased compared to before. The code has changed a lot, and nothing looks like before. The VM Protect tool itself includes a huge number of methods to prevent reverse engineering. It can even block debuggers. As you can see, it detects that we are debugging it. But the performance in this method drops significantly. It might not be suitable for use in games. In normal mode, you can see it runs correctly. Alright, I hope you have gained a good mindset about the methods I have discussed, because in the next videos, we're going to learn about deobfuscation. Thanks for watching.